All right, here is question 15. So here we have a certain character, John, and he's climbing a hill whose shape is given by this equation. Z is 1000 minus 0.01 x squared minus 0.02 y squared. So what does it mean? It means that the shape of the hill is given by, well, as a graph of this function. So this is what it looks like, right? So it kind of yeah, I mean, I'm not sure how to make it to level it, but yeah, you I hope you are getting the idea, right? So the direction of the z-axis is yeah, I guess that's it. Is the vertical direction, and z is basically like the height of the hill, either above the ground or above the sea level or whatever. It doesn't matter, right? And this character John is somewhere on this hill, and he's walking somewhere. Okay, so x, y, and z are measured in meters. So John is standing at a point with coordinates. So here x is 50, y is 80, and z is 847. So I will not check it. I guess it's correct, right? So basically we don't really need z because if we know x and y, then just z is given by the equation. So we probably don't really need the value of z here. The positive x-axis points east and the positive y-axis points north. All right. And if John walks northwest, right? So basically we have something like this. So this is east, this is north. So northwest is, I guess, is this direction. Will he start to ascend or descend? All right. So we need to figure out what this direction is, and we need to figure out whether the directional derivative is positive or negative. Right? So ascend means that the directional derivative, because the the z of John's position, um, it is his height above the ground, right? So if it is increasing, it means that he is ascending. So ascend means that the z is increasing, so which means that its derivative is going to be positive, and descend means that the derivative is going to be negative. And at what rate? So at what rate? So here we just need to find the directional derivative of this z at the given point. At which direction? So in part B, in which direction is the slope largest? So which means that um, basically this is at which direction is our function increases most rapidly, and the answer to this part is just the nebula z, right? And what is the rate of ascent in that direction? And the answer is norm of nebula z. So I guess we can just start doing the question. The first thing that we need to do is probably it is probably a good idea to see what's going on here. So this is our coordinate axis, so x and y. I'm not going to draw z, right? So if you're interested in z, so you can just plot a graph in the 3D space. Yeah, this is what it's going to look like. So the point x is 50, y is 80, right? So I guess this is the initial point. So it's like 50, and it's going to be like 80. This is the initial point. Okay, so the direction, so the x direction is actually uh, uh, is is east, right? So this is east and this is north. And notice that um, in part A, the question is about northwest, right? And since it's no northwest, so west will be here. So northwest is actually this direction. So the northwest direction is in fact the direction parallel, well, along the line with coordinates, along the vector with coordinates negative 1 1. All right, so I think we can just start doing the question. So I have just rephrased it. So in part A, the question is about the direction uh, of the vector negative 1, 1. But this is not a unit vector, so when we're doing directional derivatives, we always need to convert our vector to a unit vector, so which means divide by its norm. And here, the norm of this vector is just square root of negative 1 squared plus 1 squared, so which is square root 2. Right, so the unit vector in that direction is um, minus square root 2, 1 over square root 2. And basically we need to find, so the question is at what rate. So the answer is the direction of the directional derivative of our function z at this vector, well, in the direction of this vector u. And basically if it is positive, then it's ascend. If it is negative, then it is descend. All right, so now to find directional derivatives, we need to do the gradient vector, so which means that partial derivatives of f with respect to x and y. So partial derivative of f with respect to x is minus 0.02x. At the given point, x is 50, so it's going to be just minus 1. The partial derivative of f with respect to y is minus 0.04y. At the given point, it is this number times 80, so it is minus 3.2. Okay, right, so our gradient vector, gradient z at the given point, I don't know, p, is minus 1 minus 3.2, and the directional derivative at the given point is going to be basically this plus this. So it's 1 over square root 2 minus 3.2 over square root 2. Well, and I guess you could just compute it, or this is minus 2.2 over square root 2. So now you could just compute it, but that's basically the answer to the question at what rate and whether he starts to ascend or descend. So this is negative, so it means descend. So the height above the ground is decreasing. I mean, we know it because the partial derivative is negative, so the height is decreasing. Sorry, not directional derivative, not the partial derivative is decreasing, so it is a descent. Okay, and part B. In which direction is the slope largest, and what is the rate of ascent in that direction? Right. So basically, it is the rate of ascent in that direction is just the norm of the gradient vector. So it's basically the norm of this vector. So rate of the fastest ascent, fastest ascent is just the norm of the gradient vector, so which is square root of 1 squared plus 3.2 squared. Yeah, and the direction in which the slope is the largest is just the gradient vector itself, right? So this direction is just the gradient vector at the given point, and it is, well, the gradient, I mean the gradient vector divided by its norm to make it unit, right? So it's going to be like minus 1 divided by square root of 1 plus 3.2 squared, and minus 3.2 divided by square root of 1 plus 3.2 squared. Well, I don't really want to compute it, so I will leave it just in this form.